All right, so the and rule for independent events can be extended to cover three or more independent events. So before we just had probability of A and B. Well, we can do now probability of A and B and C. If they're all independent, then we get probability of A and B and C is equal to probability of A times the probability of B times the probability of C. Okay, so that's going to be one key thing. Now, what about the probability of an event happening at least once? Well, that means the probability of that event is equal to 1 minus the probability that the event does not happen. So that's going to be an equation we're going to have to use on some problems. And so knowing both of these will help us in the future to figure out some of these problems that they will assign us. So what about the probability of a family having four boys in a row? Well, what's the probability first of a boy? Well, okay, probability of a boy is equal to 1/2 because you either get a boy or you get a girl. So what about the probability of a boy and a boy and a boy and a boy? Now, are these independent? Yeah. The probability of this one doesn't affect that one or that one or that one or vice versa. And so we can just take the probability of a boy times the probability of boy times the probability of the boy times the probability of the boy. Oh, well, 1 times 1 times 1 times 1 is 1, and 2 times 2 is 4, times 4 is 16. What if I had asked instead, what's the probability of a girl and a girl and a girl and a girl? Well, guess what? Probability of a girl is also 1/2, so it's going to be same thing. It's going to be 1/16. So it doesn't matter in this one which way you go, all boys or all girls, both of them are going to give you the probability of 1/16. All right, so let's stop there and we'll come back for some more.